Hello, everyone, and welcome back to our weekly series on learning about the concepts of object-oriented programming in Python. Now, we have been going in depth in Python, trying to understand the various different topics which are considered to be a part of object-oriented programming. Today, we are going to talk about something known as design patterns. Now, what are these design patterns? These design patterns will allow you to construct your code in such a way that you will have the ability for it to be created for very, very specific tasks. Okay. Now, there are multiple design patterns that one could use. Okay. So today we are going to focus on three very important patterns. Okay. And we're going to try to see and look at the code for those patterns. We have something known as the singleton pattern. Now, what exactly is the singleton pattern? Okay. What do we mean by the term singleton? Singleton is essentially designed to restrict the instantiation of our classes. And it will only create a single instance of whatever class that you're looking for. Okay. So this will ensure that you always have a global point of access to that particular instance. Okay. So this is very commonly used. So let's talk about some basic use cases. Some basic use cases of singleton pattern are basically systems which require only a single instance of the class. Okay, that's it. Now, what are these single instances? We are talking about logging. Okay, we are looking at config settings, and we are also looking at database connections. Okay, these are the basic instances where singleton pattern is used. Okay, so now let's take a look at the structure of our singleton pattern. Okay, so what is the overall way in which the code is written for singleton, right? So let's create a class here, and let's call this class as singleton. This is the basic structure that we follow. Okay, this is obviously something that you do when you're dealing with each and every single object that you create. Now, in this instance, I will create a variable called instance, and I will initialize that as null. Okay, we are going to initialize that value as null. Okay, so here, what we will do is we will say create a user-defined function or create a method within the class, and we will say new class. Okay, within our existing class. And we will say that if the instance is none, which it is, because we have initially declared our instance as none, right? So we created a custom class and then we declared it as none. Okay. So then what we will say is cls.instance is super class. Okay. We are going to create a super object. Okay. We are going to initialize a super object here. We will say singleton, which is the name of our class. Okay. And then we will say CLS, which is a method that we have created, dot new CLS. Okay. And then we will just return our CLS instance. Okay. So as you can see here, we are essentially limiting ourselves to a single usage of this class. So let's create this class. Let's activate the class, and then we will simply call the method. So I'll create a couple of variables, singleton1, which I will initialize as singleton, and singleton2, which I will also initialize as singleton. Now, normally, whenever we initialize any method, right, what happens? It will create multiple instances of those classes. Okay, multiple instances are created, and multiple instances are then taken and okay. But here in this case, I will 1 second. CLS. This should have been underscore here in both the cases, right? Because that is the name that we have given to the variable there. Okay. So we will now create our instances of the class. Now, what I want to see is whether these are separate methods or whether these are the same method. So basic, we will just create a print statement. We will say singleton1 is singleton, and the output is true. They are both the same instance of the same class. So instead of creating multiple instances, we are going to have only a single class. Okay. Now, what are the benefits of using singleton? Why do we need to use this specific method? First is resource efficiency. This singleton class that you're looking at is highly resource efficient because we reduce the overhead and we reduce the overhead because we are only creating one instance or one object and we are reusing it. Instead of creating multiple objects, creating multiple instances of the class, we are just creating a single instance and we keep on reusing it. Okay. Then there is also a consistency element which is involved. So we can also say that we have a consistent state. Okay. So we are saying that since there is just one instance which exists, okay, changes in the state that we are making that instance are visible to all that have access. So basically, whenever you create a singleton instance, right? And you give access to certain parts of your code for this. All of them will have the visibility for any change in the state. Okay. Then we have global access point. Okay. So you get a centralized access point because everything is referring to the same thing within this class. Everything is calling the same thing. So you get centralized access for a global function. For example, something basic like logging into a database or creating a logging mechanism or some kind of configuration file settings. It, all of them have a single access point. Okay. So these are the benefits. Okay. However, we have to be careful of the global states because if you are not careful, you might accidentally create unwanted global states. Okay. And it is also difficult in testing because you're carry the state. Okay, you're carrying whatever state that you have initialized across the entire application. So as a result, it will make the testing of the applications more complex in nature. Okay. So this is what our singleton class is all about. Now, let's take a look at the next method of our design patterns. And the next method is more complex. Okay. So we will look at how it works, what are the different logic that we follow in this pattern. This is known as a factory pattern. Okay. Now, what exactly is a factory pattern? So this is basically like an interface for creating objects. Okay. But it will also allow any subclass to or any method that you create to decide which class to instantiate. Okay. So which class do you want, or which instance or which method do you want to instantiate? You can decide it. And very importantly, okay, it will decouple. Decouple basically means a sort of de-attachment, or it just allows you some more flexibility, right? When we talk about the term decouple, right, it's basically like, how we have trains. Now, a train is carried by an engine, okay? And the engine is pulling the train, it pulls it into a certain station, but now it needs to change the direction. How can it change the direction? The change in the direction happens because of something known as decoupling. So basically, the engine will remove itself from the wagons, okay, and it will then take the different direction that it wants to do, okay, and then it will just come back on the other side and reattach itself. Okay, so this is the process that we want to decouple. Okay. So basically, the factory pattern will decouple object creation from the code. Okay. So there is a degree of separation or disengagement between the creation of objects and the codes which are going to use these objects. Okay. So as a result, we have a lot of flexibility. Okay. Now, some flexibility like this can create, can lead to something that is very useful. Okay. So there are certain points that we need to remember about factory pattern. First is we are looking at encapsulation of object creation. Now, encapsulation is a very important concept of object-oriented programming. So what exactly am I talking about here? So my object creation logic is separated from the client. Okay. So whoever is the client, they can work with interfaces. Okay. They're going to work with interfaces rather than specific implementations. Okay. And then also it promotes loose coupling. And it promotes loose coupling in the context that the client code is decoupled from the class because it works with the factory. And the factory is responsible for object creation. You can think of it like this. You are purchasing some product. For example, you're purchasing a hammer. Now, when you go to purchase the hammer, they're not going to make the hammer in front of you, right? They're not going to create the hammer in front of you. Even if you put in specific demands, okay, for the hammer that you want to create, they're going to go and look at it in a workshop. And then the workshop is going to create the hammer, and then it will be delivered to you. So similarly, as a client, you have an application which has multi-client support. Okay. So as a result, this multi-client support, each and every object that is created for a specific client is going to be isolated from one another. Okay. So this is how our factory pattern is going to work. Now that we have an idea on how the factory pattern is going to work, let's take a look at the code which is used in the factory pattern. Okay, so let's start creating some superclasses and subclasses. Okay, let's create a class known as animal. Okay, and here we will create a method within this class. All right, and this method is going to raise an not implemented error. Okay, so not implemented error, and the error message that we are going to raise here is subclass must implement abstract method. So we are going to create this class known as animal. Then we can create multiple classes here. Okay. These multiple classes are going to refer to our main class, which is the animal class. Okay. So we will say class dog, and this will refer to the animal class. Okay. And then I will create another method, the same method, which is there. And we will call this as, we'll give some return value here. Okay. So now we have created a superclass and a subclass. Okay. Then let's create another one. Okay. Let's create another class and let's see how that other class works. Okay. We will say a class called cat, and then within this class called cat, we will call our animal. And then we will say speak self, and then I will return meow. Okay. These are the different classes that we are looking at. Okay. So now we have created different abstract methods. Okay. Something that we have already learned about, something that we have already discussed and talked about. Okay. So now what to do with these abstract methods? Okay. So let's look at another class and let's call this animal fact. Okay. And within this class, we will create a static method. Okay. So now what does this static method do for us? The static method is a method which belongs to the class itself. Okay. So this method is essentially created for the class. Okay. So this static method that we have created now, okay, within this static method, let's create a method here. Let's say we will say this get animal, and here we will have an input coming in as animal type, and then we will simply create a few basic conditional statements. If animal type is equal to dog, then we will say return dog, return the class dog. Then we have another type here, right? We will say if animal type is elif, sorry, animal type is cat, then it should return the subclass called cat. Okay. Else we wanted to return a value error, which will simply say unknown animal type detect. Okay. Now, this is how the structure for a factory code is written. You can see that the difference instances which we have created. We have animal factory. Okay. So in terms of animal factory, we are looking at a static method. Okay. So here, let's run this instance and let's look at some basic usage. So I'll initialize an instance called factory. Now, if you notice something, the initialization that I am doing here is for my animal factory class. I'm not calling the animal class. I'm not calling the dog class, and I am not calling the cat class. Instead, I am only calling the animal factory. And the animal factory is going to point to the other methods which I have created. Okay. So let's initialize this and let's give an animal here. So we'll say factory dot get animal, okay, which is the name of our method. And within this, we will pass some input. Okay. Get, oops, get animal, right? And then I will just say print animal dot speak. Okay. And we will get the output here. As you can see, I am not calling the dog class directly. I'm also not calling the animal class directly, although I am referring to my animal class in the dog class. Same goes for the cat, obviously. Okay. So this is how our factory method will work. Okay. So here there is no reference to the dog class. The client that is going to be using this code, they're going to be looking at the animal factory method. They're going to be looking at directly, they're not going to be looking at the dog or the class or the cat method. Okay. So if you look at, for example, the help, and here you pass animal factory as the class. Okay. So here you can see that the documentation is simply referring to the animal factory. If a person is using this specific class, they're not going to be able to look back at the original class. Okay. And they're not going to be able to use the original class. Okay. They're simply going to be able to look at whatever class we are providing them. Okay. This has a lot of benefits, as we have heavily talked about uh, decoupling concept, right? It just ensures that the class creation is separated from the client code so that there is no interface, no interference. Okay. You can introduce multiple objects, new types of objects in this method without having to create or without having to modifying any kind of existing code. Okay. And of course, loose coupling is important. This is a lot. This is heavily used in two very important things. This is used in GUI development. So creating buttons, text fields in various different UI frameworks. Okay. So for example, we have a Linux machine, we have a Windows machine, and we have a Mac, right? All of them have different interfaces. So you can use a method like this to create a class set. This is also very useful in things like game development. So you can create different types of characters, weapons, game levels, etc. So these are the two design patterns that we were going to talk about today. Of course, there are multiple other design patterns, and we encourage everyone to take a look at them, right? So thank you so much, everyone, and we'll see you next week.